My name is Seth. I'm going to be giving a talk on breaking down the web of trust. So I'm just going to talk a little bit about trust metrics used in OpenPGP, why there are a lot of good key signing practices out there, and why, unfortunately, why most people don't seem to follow them and all the problems that PKI has as a result. And try to get people to see good key signing practices, hopefully apply it to the key signing party immediately afterwards here, and hopefully use it to strengthen the web of trust in general in the future. So if I'm going too fast or if I'm speaking in a way that's hard to understand, please don't hesitate to raise your hand and try to get me to stop. Also, if you have a question at any time, don't hesitate to get my attention, even if you have to shout or throw something at me to get me to notice. Just get my attention and say, hey, I've got a question, hey, I don't understand, and I'll do my best to explain it for you. So before we begin the full talk, I would like to ask, how many people here use PGP or GPG or something of the sort? Excellent. How many people are going to the key signing party afterwards? Cool. Why aren't you all going? Seriously, like, you should stick around, at least try to get some signatures. It's always good. But here's a key.
You don't have to attend to get signatures.
I don't know who was doing that last year, but that's really not good. So here's, I don't know who has it. I've got mine. You guys have yours somewhere. So here's a key. Here is the information for a public key. Who here would sign this key, given the opportunity? All right, I have one person in the entire room who would sign this key. Why would you do it?
Well, if I knew who Ultra Laser was, and if I knew him personally, I'd be willing to sign this key.
Even though the name on the key has numbers in it?
Yes, absolutely. If I know him as Ultra Laser, then I would more than happily sign his key as such.
Okay, who thinks this guy is full of it? All right, can I see a show of hands? Who thinks like this guy is completely wrong?
What did he say? Could you repeat it?
He said that if he knew the person as Ultra Laser, he would sign the key, even if like he didn't have a photo ID showing that the guy's name was Ultra Laser. No, nobody wants to take the other viewpoint? No? Okay, well, this is something to think about over the course of the talk. This is one of the things I'm going to mention, but keep this key in mind because it's a very good example, and situations like this have actually come up recently at key signing parties I've attended. And I guess what would you need to know before you did? He mentioned, if this guy is known as Ultra Laser, but who would want to see a photo ID with Ultra Laser on it? You would trust a photo ID if it had that as the name on it?
Adam Smasher.
That's his legal name. All right. So I want to start off by talking about the web of trust. And why is it that we need a web of trust? So my key, that's the key ID at the top. And these are some key IDs of people that I know and I've verified and I've signed. But the point of the web of trust is to be able to believe that a key is valid and that a key it belongs to who they say it belongs to, even if you've never met the person before. This is a very interesting problem. The biggest problem with public key cryptography is the PKI problems involved. It's easy to do the cryptography. The protocols for having it be trustworthy are difficult. So anybody can run through the RSA algorithm or Elgamal or whatever and encrypt something, but encryption is absolutely worthless if you're not sure that the person that you're encrypting to is the person that you really want to get the message. So if I want to send a message to you and I'm really encrypting to her, then the encryption is worse than worthless because I think I'm safe and I'm really not. So you want to make sure that the goal is to have nobody else able to read your message. The goal is not to just encrypt the message. Encryption isn't the solution. You have to use it properly in order for it to satisfy your needs. So the whole point is to trust the validity of keys you've never seen before. And to do this, there are a number of different components, and trusting other people's ability to make good decisions is one of them. And as we all know from a day-to-day basis, we probably all know from a day-to-day basis, trusting other people, even for the most simplest of things, is a non-trivial task. So here's an example web of trust. I'm not sure whose this is. I just grabbed an image because I didn't have GraphViz installed at the time of doing my slides. But each of these circles belongs to a person, and it refers to their key. And you can view the web of trust as a graph, in the graph theory sense, not in the general mathematics, line going everywhere sense. You have vertices, which in this case are people's keys, and you have edges between the vertices, which are signatures. And each signature is a directed arrow. So you can see on this graph that the arrows are not two ways. You can have a non-mutual signature set between different keys. So I can sign your key, but that doesn't mean that you've signed my key. And this is perfectly acceptable, and it's pretty common because a lot of people go to key signing parties and say they're going to sign everybody's keys, and then they don't. So this happens. It's not a bad thing. It's just something you have to keep into consideration when looking at signature lists and trying to calculate trust metrics. At the bottom, there's an example of what it looks like as output from GPG. So it lists the user ID that I have on my key. It's got my name and my email address in it. And here are a couple of example signatures. Two of them I actually got from the key signing party here last year. It also has names and email addresses in them. And by these people having signed my key, it means that they trust the key and they trust my identity. So that means both my name, and they've checked photo ID of mine, and my email address, where they've sent the key to my email address so that they know the email address is working if I end up getting the signatures uploaded to a key server. Yes?
Is it a good idea to say I trust this email address because the security of an email address, POP or SMTP IMAP, is more or less nothing? Is it a good idea to say I trust this email address? Isn't it enough to say I trust the name?
Personal preference. The security on a lot of email addresses is crap, but there's no way to easily prove this. If somebody else has sniffed a password and can read their email address or their emails, it doesn't really benefit them to grab the signature and upload it to the key server if everything else still checks out. One of the problems here, and you've just noticed this, that I'm going to get into, is that the name and the email address are inseparable. If you want to verify one, you have to also show that you trust the other. There's no way to say I trust the name or the email address. There's no way to say I trust this range of bytes in the UID. It's all or nothing. And this is a problem that I'm going to get into a little bit later. So yes, that is a problem. One thing about the web of trust is everybody calls it the web of trust, but there's actually two different aspects to it. There's the web of trust and what I like to call the web of validation. When you sign somebody's key, you are not saying that you trust their judgment. You are saying that you trust that the key belongs to them. So signing a key validates the key. You are saying, I think that it is okay to use this key, and I think that the person is who they claim to be on the key, and I believe that the cryptographic material in the key is accurate and it hasn't been changed in transit. There's been no man-in-the-middle attack. You are saying, I think this key is trustworthy for me to use, and that's all you're saying. There's a second part that a lot of people seem to forget, and that second part is the actual web of trust. You're not saying, I trust this key. You're saying, I trust the owner of this key to make introductions for me. So if I were to sign your key, then I'm saying your key is valid, and I will use it to communicate with you. But then I have to set an additional parameter saying, I don't trust your introductions, or I do trust your introductions completely, or I only trust them partially. And that's the second step that lets you trust the key of somebody you haven't met, that you don't know at all. And a lot of people completely miss this step, even though it is the most critical step in the web of trust, because without it, you wouldn't be able to trust anybody beyond one hop. So a signed key is validated. An unsigned key may or may not be trusted based on whether you trust people who have signed that key. So to build that web of trust, in GPG, you use the command update trustdb, and it will run through your keyring, and it will look for any keys that you've signed, and it will ask you whether you trust that person to sign other keys. So in this case, it sees that there's a key that I have not assigned a trust value to. In GPG, there's a trustdb file. It is completely separate from the keyring that handles all of the trust values. Nobody else ever sees these values. So you can say, I don't trust this person, and you don't need to worry about it getting back to them because it's used for you only. It's all personal, and this is potentially sensitive information that somebody else can get upset if you happen to say to somebody, I don't trust you. They might say, okay, well then, even though I should, I don't trust you anymore, and everything breaks down very quickly. So this is very personal information. It never goes anywhere else. You shouldn't feel ashamed to say, I do not trust this person's judgment. If you have any doubts at all, you should say, I don't trust them. Err on the side of caution. So again, there are different levels of validity or trust that you can assign to the key. The default is I don't know. And in this case, the key will not be used in building your personal web of trust. You can say, I don't trust it, in which case this person's signature on another person's key will be worthless. Then you can say, I trust it marginally or I trust it fully. If you trust it fully, any key that is signed by this key will automatically be good. If you say you trust it marginally, then there's a user-defined threshold of how many marginals you need in order to have something be valid. So in most default cases, this is 3. So you need 3 marginal signatures or marginal trust values for it to be a good key. You can customize this. You can say, well, 2 is good enough. You can say 10 is good enough. But it's completely up to you. And as an example of validity versus trust, here's the key of a friend of mine from back home. She's laughing because she knows exactly who I'm talking about, but his key is valid. I would use his key to send him an encrypted message because I know for a fact he is who he claims to be, both his name and his handle and his email address, and I know that the key material in his key is correct. However, the guy has no idea what he's doing with cryptography. He has no clue. He's the kind of person that should not be using cryptography. And if he signs somebody else's key, that means nothing to me. So I trust his key to send messages to him. I do not trust signatures from his key on other people for me to trust other people's keys. So this is the difference between validity and trust. His key is valid, but he is never trusted. Everybody with me so far? Excellent. Okay, so that's the quick and dirty introduction to the web of trust. Almost everybody here says that they use this system, so I try not to stick on it for too long because I'm sure you already know all this. But let's get into the interesting things now. The goals of the web of trust are to verify that a key is accurate. And to do this, you check the fingerprint. So you want to make sure that there has not been a man-in-the-middle attack, somebody else putting different keys into a key exchange so that if Alice sends a message, it's really encrypted to Mallory, Mallory decrypts it, re-encrypts it, sends it to Bob, and then vice versa on the way back. You want to make sure that the person who owns the key is saying, this is really my key, not any other key, just this one. You also want to make sure that the key ownership is accurate. So you want to make sure that the name on the key is really the person who they claim to be. So if my key had the name of George Bush on it, even if I said, well, this is the right fingerprint on the key, somebody shouldn't sign it because I'm claiming to be somebody different than who I really am. And I certainly hope nobody would mistake me for him, but you want to make sure that the data is going to who you want it to go to.